Hello dear students, welcome to my new video. Today we are going to discuss the chapter Binomial theorem and the topic is general and middle term. We have discussed binomial theorem and some examples and special cases for binomial theorem and example for that. Next topic is general and middle term of binomial theorem. We know that binomial expansion of a plus b all raised to n equal to nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b square plus etc. We know that the first term of this expansion is nc0 a raised to n. The second term is nc1 a raised to n minus 1 into b. And third term is nc2 a raised to n minus 2 into b square. It goes on. Therefore, we can write r plus 1th term is NCR a raised to n minus r b raised to r. By looking first, second, third term, we can write r plus 1th term as NCR a raised to n minus r into b raised to r. Therefore, r plus 1th term is general term of expansion a plus b all raised to n. It is denoted by t of r plus 1. The general term is denoted by t of r plus 1, which is equal to NCR a raised to n minus r b raised to r. This is the general term of expansion a plus b all raised to n. Next, middle term of the expansion a plus b all raised to n. That has two cases. First one, if n is even, the number of term in expansion will be n plus 1. That is common. The number of term in expansion is n plus 1. Since n is even, n plus 1 is odd. We know that n is even, therefore n plus 1 is odd. Therefore, the middle term is n plus 1. That is the total number of terms plus 1 by 2th term. That is, we can write n by 2 plus 1th term. This is the middle term. That is first case, if n is even, the total number of terms in expansion is n plus 1. So, since n is even, we can say that n plus 1th term is odd. N plus 1 is odd. Therefore, middle term is n plus 1 by 2 the term. That is, n by 2 plus 1th term is the middle term if n is even. For example, in the expansion of x plus 2y all raised to 8, here n equal to 8, that is even. Therefore, middle term is n by 2 plus 1th term, which is equal to 8 by 2 plus 1 is equal to 4 plus 1, which is equal to fifth term is the middle term. Next, second case, if n is odd, then n plus 1 is even. So there will be two middle term because this is a even number. That is, the middle terms are n plus 1 by 2th term and n plus 1 by 2 plus 1th term. These two are the two middle term if n is odd. For example, in the expansion of 2x minus y all raised to 7, the middle terms are first n plus 1 by 2, which is equal to 7 plus 1 by 2 is 8 by 2 equal to 4th term, and next n plus 1 by 2 plus 1, which is equal to 7 plus 1 by 2 plus 1, which is equal to 4 plus 1, which is equal to fifth term. That is, fourth and fifth term is the middle term of the expansion 2x minus y raised to 7. That is, if we have n is even, we have one middle term, and if n is odd, we have two middle terms. Also, we have another term, that is term independent of x or constant term. Constant term, that is, besides in middle term and general term, we also have constant term or term independent of x. We can see that term in the expansion of x plus 1 by x all raised to 2n, where x not equal to 0, the middle term is is 2n plus 1 plus 1 by 2th term. That is, n plus 1th term, as 2n is even. Therefore, we can write 2NCN x raised to n 1 by x equal to 2NCN, which is constant. Therefore, this term is called constant term or term independent of x. That is, this term does not have x term, it is a constant. Next, we can discuss some problems. First one, find A if the 17th and 18th terms of the expansion 2 plus A all raised to 50 are equal. Solution. The r plus 1th term of expansion x plus y all raised to of x plus y whole raised to n is given by T of r plus 1 equal to NCR x raised to n minus r y raised to r. For the 17th term, we have r plus 1 equal to 17, that is r equal to 16. Therefore, T17 equal to T16 plus 1, which can be written as 50C16, that is R is 16, 50C16, x equal to 2 into n minus r, that is 50 minus 16 into y equal to a, then a raised to 16, that is y raised to r is equal to a raised to 16, which can be written as 50C16 2 raised to 34 into a raised to 16. Similarly, we can write T18 equal to 50C17 2 raised to 33 into a raised to 17. Also, we know that T17 equal to T18. That is given in the question. 17 and 18 terms are equal. Therefore, we can write 50C16 2 raised to 34 into a raised to 16 equal to 50C70 2 raised to 33 a raised to 17. Okay, if two terms are equal, we can equate the two terms. Therefore, we can write 50C16 2 raised to 34 divided by 50C17 2 raised to 33 equal to a raised to 17 divided by a raised to 16. That is a equal to 50C16 into 2 divided by 50C17. That is 2 raised to 34 divided by 2 raised to 33 equal to 2. Then 50C16 by 50C17, which is equal to 50 factorial divided by 16 factorial into 34 factorial into 17 factorial into 33 factorial divided by 50 factorial into 2. That we write the formula for the combination. 50C16 equal to 50 factorial divided by 16 factorial into 34 factorial into 15C17 equal to 17 factorial into 33 factorial divided by 50 factorial into 2, which is equal to 50 cancel. We got answer as 1. Next problem, find the coefficient of x raised to 6 y cube in the expansion of x plus 2y all raised to 9. We have to find the coefficient of x raised to 6 y cube in the expansion of x plus 2y all raised to 9. Solution. Suppose x raised to 6 y cube occurs in the r plus 1th term of expansion x plus 2y all raised to 9. We can consider x raised to 6 y cube occurs at r plus 1th term. Of expansion x plus 2y all raised to 9. Therefore, we can write T of r plus 1 equal to 9CR. We don't know the value of r, but we know the value of n equal to 9. 9CR x raised to 9 minus R 2y raised to R. This is the R plus 1th term equation, which is equal to, we can write coefficient together, 9CR 2 raised to R. This is the coefficient, then remaining term is x raised to 9 minus R y raised to R. So if we compare the indices of x raised to 9 minus R y raised to R and the indices of the given equation x raised to 6 y cube, we can write 9 minus R equal to 6, R equal to 9 minus 6, which is equal to 3. Therefore, coefficient of x raised to 6 y cube will be 9C3 2 raised to 3. This is the coefficient. This is the term x raised to 9 minus R y raised to R, that is x raised to 6 y raised to 6, which is equal to 9 factorial divided by 3 factorial into 6 factorial, that is 9 factorial divided by equation is NCR equal to n factorial divided by R factorial into n minus R factorial. That is, we can apply here, n is 9, 9 factorial divided by R is 3, 3 factorial into n minus R, 9 minus 3 equal to 6 factorial. That we got here into 2 cube. We can write 9 into 8 into 7 into other term is 6 into 5 into, that is 6 factorial, that we can cut from denominator, and 3 into 2 into 1, that is 3 factorial into 2 cube. Which is equal to 672. This is the coefficient of the term x raised to 6 y cube. Next problem. Show that the middle term of the expansion of 1 plus x all raised to 2n is 1 into 3 into 5 into etc. into 2n minus 1 by n factorial into 2n x raised to n, where n is a positive integer. We have to show that the middle term is 1 into 3 into 5 into etc. into 2n minus 1 by n factorial into 2n x raised to n of the expansion 1 plus x all raised to 2n. Solution. As 2n is even, the middle term of expansion 1 plus x all raised to 2n is 2n by 2 plus 1th term, that is n plus 1th term. N plus 1th term is the middle term of the expansion. Therefore, T of n plus 1 equal to 2n Cn 1 raised to 2n minus n and x raised to n, which is equal to 2n Cn 1 raised to 2n minus n equal to 1, then x raised to n, which can be written as 2n factorial divided by n factorial into 2n minus n, that is n factorial into x raised to n. We write 2n cn as 2n factorial divided by n factorial into n minus r, that is 2n minus n, which is equal to n factorial, which is equal to 2n into 2n minus 1 into 2n minus 2 into etc. into 4 into can notate multiply by dot 4 into 3 into 2 into 1 divided by n factorial into n factorial x raised to n. That we write that 2n factorial as 2n into 2n minus 1 into 2n minus 2 into etc. into 4 into 3 into 2 into 1. Then we can rearrange the terms 1 into 2 into 3 into 4 into etc. into 2n minus 2 into 2n minus 1 into 2n divided by n factorial into n factorial into x raised to n. Next we can write 1 into 3 into 5 into etc. 2n minus 1 into 2 into 4 into 6 into etc. 2n divided by n factorial into n factorial into x raised to n. That we arrange the above term as even numbers and odd numbers. This is odd numbers, this is even number. Then we can write 1 into 3 into 5 into etc. into 2n minus 1. We can take 2 raised to n outside. 1 into 2 into 3 into etc. into n divided by n factorial into n factorial x raised to n, which is equal to 1 into 3 into 5 into etc. into 2n minus 1 into n factorial divided by n factorial into n factorial 2 raised to n x raised to n. That we write 1 into 2 into etc. into n as n factorial, then 2 raised to n right here, then x raised to n. Then we can cut 1 n factorial, then the equation is 1 into 3 into 5 into etc. into 2n minus 1 divided by n factorial 2 raised to n x raised to n. This is the required form. The question is given that we have to prove the middle term as 1 into 3 into 5 into etc. into 2n minus 1 by n factorial into 2 raised to n x raised to n, which we got here. This is the required answer.